Welcome to the intersection of technology, cybersecurity, and society. Welcome to ITSPmagazine. You're listening to a new Redefining Security podcast. Have you ever thought that we are selling cybersecurity insincerely, buying it indiscriminately, and deploying it ineffectively? Perhaps we are. So let's look at how we can organize a successful InfoSec program that integrates people, process, technology, and culture to drive growth and protect business value. Knowledge is power, now more than ever. HITRUST is a leading data protection standards development and certification organization that strives to safeguard sensitive information and manage information risk for global organizations across all industries and throughout the third-party supply chain. Learn more at hightrustalliance.net.
Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.
You are very welcome to a new episode of Redefining Cybersecurity here on ITSPmagazine. This is Sean Martin, and as many folks know, I love security. I love security data analytics, and when I saw the opportunity come across to speak with David Bader about this topic, I was like, it's game time. Let's have some fun with this. I'm thrilled to welcome David to the show. We're going to talk about kind of the current state of data analytics for cybersecurity and more importantly, some of the cool stuff David's working on to set us up for a positive future, hopefully, with respect to protecting our businesses and information that's within them. So David, thanks for joining us.
Thanks, Sean. I'm glad to be here on the podcast and with your listeners. And for those of you out there, my name is David Bader. I'm a distinguished professor of data science at the New Jersey Institute of Technology, and I also am the inaugural director of our Institute for Data Science. I love to work on research in large-scale graph analytics and large-scale data science, and I'm looking forward to talking about it with you today.
And as I was reading some of your bio, I mean, you've done some incredible things. Supercomputer is one that comes to mind, and it's interesting kind of look back, and maybe this is our jumping off point, because computers weren't super, right? We had mainframes, and we had desktops that are pretty powerful. The phones in our hands are even more powerful than some of those. But I'm wondering, are we even at a widespread supercomputing capacity for the everyday business? Well, maybe let's start with that first.
Well, great question. And, looking back on history, we had supercomputers that were really $1 million devices, usually in the hands of governments or just the largest companies out there. And back in the late 90s, I invented the Linux supercomputer that now has taken hold. In fact, all the major supercomputers in the world are based on the design that I had. And last fall, I received the Sidney Fernbach Award from the IEEE in recognition of that. So today we have our desktops and our laptops. And, if we were able to transport back in history, my laptop here today would have been one of the 500 fastest supercomputers 7 years ago. So if you think about it, the gap between our computers that we're using on our desktops today and a supercomputer of just a few years ago is only about 7 years. So we have to keep thinking, with all of this capability, what can we do with it? And as we start looking at the most capable systems today, in fact, the world is in a big competition to create an exascale supercomputer. And what that means is in about 7 years, that's the type of capability we're going to have around the office. So it's great to start planning ahead to think, what will we do with all of that capability for both compute intensive jobs, but also data intensive supercomputing as well?
Yeah, the answer is NFTs, David, NFTs.
And I hope to be a part of that.
Everybody's going to make millions off NFTs, I'm sure, with supercomputing. No, I joke, but so I'm going to keep cybersecurity separate for a moment, and that's going to be purposeful. But the state of data analytics as a big bucket of technology and capabilities, where do we sit at the current moment? Who's leveraging the technology to the most benefit of their business or their outcome that they're trying to achieve? Where do we see some room for improvement there, perhaps?
We're really at the infancy of data analytics. There are some tools that are emerging, for instance, using machine learning across all types of problems within our industries. And we see it being used in multiple sectors, from security to transportation to gaming and entertainment to food production and even health and medicine and on and on. But there are other techniques as well that are emerging. For instance, graph analytics that I'd love to continue talking about on this podcast, and other types of AI and machine learning techniques I think are still growing. So it's a fantastic time. And the industries are also broader than just our IT sector. For instance, at NJIT, my Institute for Data Science has an advisory board, and we have investment banks, for instance, Citibank on our board, newspapers like the New York Times, manufacturers like Stanley Black & Decker, as well as companies like Amazon and Google, Accenture, and others. So we see this being used, data science continuing to grow, for both helping to create better products, to keep us safer, to make better decisions, data-informed decisions, and on and on. This is also why at NJIT we launched a Department of Data Science this past fall with bachelor's, master's, and PhD programs to really train that next workforce who are going to go out and work in the many broad sectors, not just in computing and technology and IT, but to really work within a variety of types of companies and industries as well. Quite an exciting time.
It is exciting. And you touched on a few examples of why investments are being made in this area: better decision-making, better products. When we talk about cybersecurity, that's clearly a risk mitigation, perhaps even a threat prevention, and maybe even a better response capability. Do you see it? Because I always have this grand vision for security, that if we're doing security right, we're actually building the thing secure from the beginning, where we eliminate the exposure from the outset, right? Rather than trying to figure out how to control it and protect it and guard against the threats afterwards. So do you see data analytics helping to drive innovation and forward-looking things that are resilient from the start, as in addition to perhaps just the after the fact? We're using data to help close the gaps and plug the holes that we created in the first place.
That's a great question. Let me address that in several different ways. So first, absolutely, with our understanding of security and the threats that are out there, we can build more resilient systems that are going to protect us from attacks. And we see more and more of that in everything that we're using, from services, two-factor authentication, more secure computers and devices. And that's fantastic to see. But we're always protecting against the threats that we know or can describe. One area that I'm really passionate about is looking for the unknowns in massive data sets. So how do you mitigate that risk? How do you try to find threats that maybe you've never seen before? These are often rare events, and typically our current techniques like machine learning get trained on patterns that we've already seen. How does that help you if you haven't seen a pattern before? So some of the work that we're doing and we're leading is building tools to help analysts search through and explore massive data sets and be able to find risks and threats or mitigate those risks before anything egregious has happened. We're developing in a large open source project called Arcuda. Arcuda is a Greek word for bear, and it's a project initially launched by the Department of Defense. And we're building out graph analytics. And we're really excited because these problems tend to be very large. And if I'm running on my laptop and my laptop has Python and my Jupyter notebook, I can search through a monetized data set. But as our data grows larger and larger into tens of terabytes, for instance, we need other solutions that give us that ease of use, that productivity, as well as fast answers. And that's where our development of large-scale graph analytics is really poised in the future to be able to solve these important problems to both governments and industry.
Now, maybe your view on this, because I may be a little ignorant, so help me out here. Supercomputer, I picture a thing with an interface capable of massive analyst power and the ability to look at the information and make sense of it there. Yeah, I guess a different model would be more of a distributed, where the data is distributed and the power is shared and the processing capabilities are shared across devices. How does one differ from the other? And is supercomputing really the only way that we can achieve what we're talking about, or are things like the cloud, or do we supercompute the cloud in a sense? I don't know what the answer is. That's why I'm saying I'm kind of ignorant here. What does that look like?
Fantastic question. And just because we're using the cloud doesn't mean that we're not using supercomputers. Many cloud offerings have high-performance computing devices on them, or, for instance, GPU acceleration. And we're able to harness these technologies, whether it's an on-premise device or whether it's in the cloud, to be able to accelerate our data science. So, for instance, we're trying to democratize large-scale data science by creating this open source Arcuda package. What we want to have is every citizen scientist or company to be able to use their Jupyter notebook, write in Python, and write their very simple analytic routines. But what we have is something that's a replacement, for instance, replacing NumPy and Pandas with some new technology from Arcuda that allows a supercomputer in the back end to run a high-performance compiler called Chapel, which is also open source, that comes from HPE Cray. And that compiler is going to do all of the heavy lifting seamlessly on the back end, giving the illusion that you're sitting at your laptop and you're just sorting through tens of terabytes of data in rapid time, just as easily as you would on your own laptop. So we're trying to democratize that supercomputing, whether it's sitting next to you in the office or whether it's on the cloud, you'll have ready access to it.
I love it. Thanks for painting that picture. That's what I was trying to envision in my head as I was asking that question. So let's bring it to security, and maybe now is a good time perhaps to talk about graph analytics. 'Cause I'm wondering, when it comes to looking at threats, or other types of risks, and I don't know, fraud can be another type of risk, which is more business, but still has an impact on the company. You mentioned the unknown unknowns. So I'm wondering how, sitting in the SOC analyst chair or the security analyst chair, how does what you're doing change the way they can interact with the data so that they can find answers to the questions they don't even know they need to ask yet?
A fantastic way to put it. So I often think about data in terms of 4 quadrants, and the quadrants are divided by patterns and objects. So in one quadrant, we have known objects and known patterns, and databases, relational databases, have been good in that sector of data analytics. In the off quadrants, off diagonal, we have known objects but unknown patterns, and we have unknown objects but known patterns. And so here we may be trying to look at a data set around individuals to see what they're up to, for instance, an insider threat case within a large organization, or we may have a pattern or template that we're looking for within the larger observed activity. And we have technologies like vertical databases to look at those. But the area that's really unique is this other quadrant where we don't know what we're holding. We're handed data sets. Maybe we sit at a company and we're collecting system logs and sensor information, internal message traffic, all sorts of information that's collected, but we don't even know what to ask of it. We've helped develop systems by tying that information together through graphs. And graphs, very simply, are a way to tie relationships together. For instance, a very simple graph is a friendship network where we as people are vertices in the graph, and our relationships, our friends, are edges that connect those vertices together. In the very same manner, we can connect together a friendship network, if you will, between computers, IP addresses, people, and other objects. And the relationships or the edges become the observations that we see. For instance, an email that's sent between two people, a file that's touched, a door that's accessed, and so on. And so now we can build up a very rich information in this graph space that tries to give us a medium where we can start to ask the questions or start to discover anomalies. And we've been very successful at this. We've worked at problems for insider threats. We've worked at problems related to cybersecurity, such as finding advanced persistent threats over long periods of time, and other domains where this is a natural way of representing that data.
I love that you gave those two examples, because that's where I was going to lead you next. And maybe you can pick one where you can expand on a little bit, because I'm wondering, as I was writing my note here, do you have a list of known, unknown problems that you're trying to solve for? Like that slow burn, advanced persistent threat, right? That's a perfect one to me, where if you don't have enough data for a long enough period of time and know what to look for in it, you're probably not going to spot it. But if you have the power, the data stores and the power, and then the interface to do that, you have a better chance. So can you pick an example that you are solving, a problem you're solving for that touches on this unknown that you've seen come through successfully?
Sure. Let's take that example of an advanced persistent threat and looking at network traffic. We know that there are some intrusions that occur with patterns over long periods of time. That may be a year, 2 years, 3 years. And there are patterns of the attack that are single edges communicated in packets across the network. If we're doing traditional machine learning and we're trying to find correlations in the data, we're often looking for obvious relationships. And we would take these types of network packets as just noise and throw them away. I think of them as being at the long end of the tail. But what we're really interested in is not those obvious correlations, but what is that one packet, what is that one network transfer that is going to be the tell for this type of novel attack? And so what we're doing is developing algorithms that can discover these types of anomalies. Maybe it's a connection from a IP address that is connecting to our border or to our network that we wouldn't expect to have a connection. And maybe it filters its way through the internet before it comes to us, and we're able to gather that information and try to understand what that actor may be up to. And so this is going to require gathering information over potentially years, and also terabytes upon terabytes of data from multiple sources to try to find maybe that single needle in a haystack, often maybe a needle in a pile of needles, to find that one tell of badness for this type of activity.
So a gazillion questions in my head. The first one, algorithms themselves. How are those defined? Are they, And maybe a step back first is, does a human define the algorithm and then the algorithm learns from data, or is that all one process? So what I'm trying to figure out is, if we're trying to give an analyst a view, do we approach it from what are they trying to uncover, or do we look at it from the attacker's side? We're not speaking cybersecurity specifically here. The attacker's side, we look at that end and say, this is what we expect we'll see based on activities we expect attackers to perform. So talk to me about that process. Who defines it? How does it learn all that stuff?
Normally, the security analyst is going to define the algorithms and the analytics, and then I help to implement those in a scalable way. Let me give you some examples. One area that I pioneered is streaming analytics, which is namely taking a state that we have and continuing to update it as we're faced with a fire hose of new data. And you could think of this as a dynamic graph that changes over time. Now, ordinarily, we would just ask a static question to this data set. For instance, is there any communication between these two IP addresses? Yes or no? Now, once that graph starts changing, we can now ask more robust questions of our data set. For instance, tell me any time there is an increase in traffic between these two locations, or tell me any time there is a change in structure of how this network is operating. Or tell me anytime there's a group of machines that are communicating with each other, but they're staying separate from the rest of the communication devices on my network. What are they up to? What are they doing? And so I can formulate algorithms that are trying to detect changes from what the current state is. And so I haven't used a learning algorithm per se, but I can put change detection within my network in a very easy way if I use these streaming analytics.
That's a great example. And I think a lot of analysts are probably sitting here. I have all these questions in my head and I have no way. I'm thinking of a standard SIM. I have no way of really getting in there to figure out what's going on here. All I can see is login attempts exceeded a certain number, right?
So
some basic rules, right?
Let me tell you about a project that we worked on a couple of years ago. And this was a project for finding insider threats within large organizations. And it was supported by a DARPA effort called Anomaly Detection at Multiple Scales. And it was really mitigating the risk of egregious events that had happened. For instance, Bradley, now Chelsea Manning, who was the alleged source for WikiLeaks, or Major Nidal Hassan, who was the Fort Hood shooter. Both of these were cleared US government personnel who had many tells that something was going wrong, but were not stopped prior to some egregious event. So within a company, imagine that you are monitoring all of the employees and they're explicitly aware that they're being monitored. Nothing is covert here. And how do you tell a difference, a change in a pattern of life? And how do you take a CISO who is getting all these threats within the company? For instance, every time a member of the staff of 100,000 people touches a file that they shouldn't have touched or goes to a web link that they shouldn't have clicked on, you can imagine those CISOs are overwhelmed with tens of thousands of alerts a day. And they're not really serious, they're not really egregious, but how do you use this graph in order to reduce the number of false positives to maybe 3 or 4 that the CISO really has to investigate that day, which are going to be the most likely to lead to some egregious event? And so we've worked on graph technologies with our partners for doing this really large-scale graph analytic to help discover these lone wolf actors, these insider threats within large organizations.
So I'm thinking of security cameras that might be installed somewhere, and there's, let's just say, it's looking at a particular wall. People can't see, right? I'm moving my head, and the sun's shining behind me as I move my head. So there's a flash of light, and the security camera might pick that up as there's movement there, right? That's an alert. If you don't look at it, you don't know that there's nothing serious going on. It's just movement in the room, and that's expected. How do we get to a point? And I guess maybe this comes in with some of the graphs that you're doing. I'm really interested in the visualization of this. So more than just a text alert, hey, something changed, something is different, something is odd. So talk to me about visualizing some of this so that you actually have some context behind what you're actually being alerted to.
When you start looking at these graph analytics and you start looking at large graphs, often they're described as big hairballs because they're very hard to visualize. Imagine I have 1 trillion items in that graph, even hundreds of billions. It's very difficult to visualize. But the metaphor that I'd like to use is these particular alerts. What I'd like is a fisheye view where I bring into focus that part of the graph that brings together the entities that were really the explanation or the rationale behind that alert. And if I can show a human who's much better at pattern recognition, the core of why that alert came to be, then a human is very good at understanding what that pattern is. For instance, do I have an attacker inside my network, or is that my soda machine that's just beginning out that we're out of diet soda? And so, it's really working in tandem with humans. I don't think these operations will replace our CISOs and replace our analysts, but using the analytics in such a way to reduce the number of threats and then to be able to visualize, as you mentioned, in a way that a human is able to interpret what's there, understand how the system came to that conclusion, and be able to then act on that information.
So let's stick with the human for a moment, because you told me that the analyst actually has to define the algorithms. So they're the core input, right? And we just talked about the human being better at pattern recognition than the machines in current state anyway. So humans on both sides of that. And I'm wondering what the role of humans have moving forward and what skills are required. Because what I'm sensing is there's this really hard problem in the middle that you're taking care of for a lot of people using supercomputing and machine learning. Not everybody's going to be able to get in there and do what you're doing there. But on the fringes of that, and as you move out, what skills do analysts need? What can they prepare for? What can they expect to get from projects like the one you're working on, so that they can focus on maybe some of those more fringe but still extremely important aspects of this?
As we start to look at data science, I think that there are going to be multiple tracks of educating the workforce. There are going to be data scientists, data analysts, and data engineers. Those that are building the tools and the systems, I think of as the data engineers who are going to have to store and process large data sets and the systems and cyber infrastructure that are going to be able to keep that information safe and process it within our quality of service times that are needed. There's data analysts who are going to be the ones that are really thinking about the new algorithms and the new processes to solve these very challenging data problems. And the data scientists are going to be more of the ones that I think of that are using the tools, that know how to pick up a Jupyter notebook and use their favorite Python packages to be able to answer questions for their employers. So I see sort of three paths. And here at NGIT, we're creating degree programs and certificates to train all three of those. I think they're all very valid uses of data science and are going to be in high demand. We already see quite a number of jobs available around the country and around the world for people who can do all three of those. For me, the interest that I have is really this data analyst, which I think is how companies that are moving forward in these data-rich problems we'll really need to engage with a data analyst who can understand what data do we have at hand, what questions can we solve with it, and then what are the next steps? What types of data scientists do we need? Where does the data sit? And what will a data engineer be able to do for collecting that data, storing it, processing it, and so on? So I think we're in the early stages of really identifying these career tracks. But if I were giving advice to a student today or someone in a company who's looking to maybe re-educate and retrain in data science, would be to take classes on data science, for instance, machine learning, data mining, data visualization, and start to get more exposure for the different types of opportunities in these different areas.
Thanks for connecting those three dots of those three roles. That's super helpful for me. And I'm wondering your vision for those roles. Do you see them as companies have all this data and therefore you have analysts, scientists and engineers looking at all the company's data, and in there is a cybersecurity data analyst and engineer and scientist? Or do you see a group specifically dedicated to cybersecurity data sets and those roles within there still separate from the business?
That's a great question. And I work with a lot of industries and a lot of companies, and I see cybersecurity may be a step ahead of other uses of data within companies. So for now, quite a number of years, there have been efforts to understand network traffic coming into companies, data being exfiltrated, and intrusions and their impacts within companies. So those risks have been known for quite some time. And there's very specialized tools already on the market for those looking at cybersecurity in view of data science types of questions and problems. Where I see more emerging trends is looking at understanding the internal workings of a company. For instance, what are the best practices of the engineers in our company? Or what makes a better salesperson in this company? Why is this woman doing great and this guy over here isn't making as many sales? What is she doing differently, and how do we replicate that? And there's also companies that are trying to understand how to monetize the data that they have. So there's many different types of questions that are both internally focused, but also externally focused. For instance, how do we have a better customer experience with our company, with our app? Or how do we understand what the buzz is on social media about our brand reputation? And then how do we address that and improve our reputation and manage that as well? We also see uses for data within the medical profession. For instance, how do we move towards personalized medicine, personalized healthcare, and really get to preventative medicine that's individualized for each person? And so I see many different roles of data, both internally focused in the company or externally focused on the customer. And cybersecurity really is cross-cutting among all of those. Anywhere where you have data, there's a risk that someone may taint that data, that they may exfiltrate it, that they may corrupt it. And so cybersecurity, I think, is overarching every type of data problem that we see across our companies and industries.
Yeah, I think we hear the need for cybersecurity and even IT to become closer to the business, understand what the business outcome objectives are and how they're operating to meet those ends. I guess as we wrap here, David, I'm trying to think what the future holds, and perhaps what security analysts listening to this might do next. Is there a way that they can see what you're working on, participate in what you're working on? I can only imagine just even a few minutes looking at what you're doing that might spark some thoughts in their mind of, well, if we only did this differently, we can take care of something serious now, and then really look forward to what David's working on as that progresses. What do you recommend?
Great question. So, of course, if you just Google search David Bader, you'll find my website with papers that we've written recently in this area. Also on GitHub, we have our CUDA project, and you'll find links to that also on my website. And it's open source code. I welcome contributors and developers to look at building large-scale data analytic software, including graph analytics. And we also have other projects, for instance, Stinger, which is our open source stream and graph framework that's highly used in industry and government. These are great ways to get involved. I welcome anyone reaching out to me, and I would love to have this conversation from everyone from new employees to CIOs, CTOs. I'd love to chat and see what we could do together. Again, I direct the Institute for Data Science at New Jersey Institute of Technology, and we have just fantastic students who are working in this area, and they're looking for internships and jobs. And this is a great way to engage with the academic community as well.
Fantastic, David. And for those listening, I'm going to include a link to David's website. It has the GitHub and all the research that he mentioned. So we'll include links to all that. And David, I mean, this is super enlightening. I used the word super on purpose. Super enlightening for me. I hope those listening enjoyed it as well. I appreciate you bringing to us the story and the work that you're doing, and really hope folks take you up on looking at the resources you've produced and are working on, and hopefully we create a better, safer business environment for everybody.
Thanks, Sean. You know, I could talk about this all day. This is, I'm so passionate about it, but hopefully your listeners have enjoyed. And again, I'd love to chat with anyone further. This is a fantastic topic, and I hope everyone out there finds something useful here and is able to adopt some of this in their work today.
Yeah. The goal is to wet their whistle, and hopefully they'll take action. And I think we accomplished that today, David. So thanks a million for joining us. Thanks everybody for catching us here on another Redefining Cybersecurity on ITSP Magazine. We'll catch you on the next one.
Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.
HITRUST is a leading data protection standards development and certification organization that strives to safeguard sensitive information and manage information risk for global organizations across all industries and throughout the third-party supply chain. Learn more at hitrustalliance.net. We hope you enjoyed this episode of Redefining Security podcast. If you learned something new and this podcast made you think, then share ITSPmagazine.com with your friends, family, and colleagues. If you represent a company and wish to associate your brand with our conversations, sponsor one or more of our podcast channels. We hope you will come back for more stories and follow us on our journey. You can always find us at the intersection of technology, cybersecurity, and society.